Hello and welcome to our video on decoders. So what is a decoder? First, let's look at something that isn't really a decoder, but a way for us to think about it. Say we have 4 light switches in a room. Pardon my drawing of a light switch, but we have 4. Number 1, number 2, number 3, and number 4. And we want to turn on these light switches. We don't know, we want to know which one to turn on, but the only problem is we only have 2 switches. Switch 1 and switch 2. Now, how do we somehow find a way to turn on all 4 of these with only 2 switches? What we do is we assign each of these a binary digit, 0 or 1. This one's 0 or 1. Let's say both of these are off. If they're both off, we can turn on light number 1. Now, if we turn this one on, or let's say we turn this one on, 0, 0 turns on light number 1, 0, 1 turns on light number 2, right here. This one gets a light now. 1, 0, so this one on, this one off, gives us light number 3. Right here we get light. And 1, 1 is light number 4. Here we get light. Now, if we do something and change these to something we're more familiar with, maybe we start with a 0, we'll see a very cool pattern. If we have this one starting at 0, 1, 2, and 3, and we go back here and reassign what they're actually equal to, 0, 0 is equal to 0. Oh, binary. 0, 1 is equal to 1. 1, 0 is equal to 2. And 1, 1 is equal to 3. That's perfect. That means now we have these 2 binary bits linked to 4 options that we can go to, and each of these can be represented in binary. This one takes 0, 0, 0, 1, 1, 0, and 1, 1. That's a decoder. Logically, we figured it out. Now let's try to put it into a gate. Say we have the same thing, switch 0, switch 1. Now, sometimes they draw this in a box saying 0, 1. Sometimes they do different abbreviations of it, but essentially this is what we're looking at. Switch 0 and switch 1. First, we want to see how do we get 0, 0. If we put switch 0 and switch 1 into A, these NOT gates will make it 0 and 0, meaning we'll get light on A. A will light up. Now we want to do 0, 1. That means our S0 should be a 0, and our S1 should be a 1. So S0 will be knotted, and S1 will not. That means we'll get light for B. Remember, A can be shown as 0, B can be shown as 1, and keep going. Now we have S0 as 0, and S1, S0 is 1, and S1 is 0, which is binary 2. And finally, if they're both 1, we get binary 3. Perfect. Now this is the implementation of a decoder from the logic we used to actual gates. Every time you hear a decoder, we have 2 inputs, sometimes more, but for now, 2 inputs that lead to 4 outputs. Now wait, does that sound familiar? 2 leads to 4. If we see a relationship here, we can see 2 to the power 2 to the 4. So for example, if we have 3 inputs, how many could we choose from? Say 3 light switches, how many could we choose from? 3 light switches means we have 0, 0, 0. These are our options, 0, 0, 0, all the way up to 1, 1, 1. That's very similar to what we can do in binary. This is 0, and it can go all the way to 1, 1, 1, which is 7, which means we have 8 options. If 3 gives us 8 and 2 gives us 4, we can clearly see that we have a relationship here between the number of select lines, the terminology select, and outputs. The correct form is 2 to the power of select lines will give us output, which means I asked you, hey, we have 5 light switches. How many different outputs can we select from? And you would say 2 to the power 5. Very, very simple. Now let's look at what a decoder looks like in a bigger circuit. Very often we don't want to draw it like this because that's a lot of complication. We can instead draw it like this and call it a decoder. And a decoder can be 2 to 4, 3 to 8, all the way up to 10 to 1, 0, 2, 4, and onward and upward to an infinite number. Because this is how, we'll get to it later, but this is how we look at memory. Let's say, for example, using a 2 to 4 decoder. We have 2 inputs and we have 4 outputs. But sometimes we have an extra input here. I'll put S0, S1, and then 0, 1, 2, 3. Sometimes we have this last input here called WE. WE stands for write enable. A write enable means, hey, are we allowing this decoder to work at all? A write enable, if it's a 0, does not let the decoder do anything. If it's a 1, will allow things to happen. That's a very simple way for us to not use decoders when we don't want to. Because if you think about it, we don't remove wires from a computer. They're always attached. So how do we make sure things are only used when we want them to? So along with our inputs, we also have a write enable, and then we have our outputs. A common question is, like I asked before, how many select lines do I need for a certain number of outputs? If I have 6 outputs, I would need I can't use 2 select lines. If I have 6 outputs, 2 will not be enough. I need more. So with 6 outputs, I would need at least 3 select lines. With 15 outputs, I would need at least 4 select lines. 2 to the power 4, 16, that covers our 15. Essentially, that's all we have to do. You've understood decoders from logically how they work, to light switches controlling 4. From an actual circuit, we have 2 inputs leading to our 4 outputs. What it means for select lines to outputs, and finally, what it looks like in an actual circuit. We have a decoder, we have our select lines, and what a write enable does. Thank you.